ተማሪዎች እንዴት ናችሁ? ብሩክ ባላለው ያው ኬሚስትሪ 11ኛ ክፍል ዩኒት 4 ላይ ደርሰናል ማለት ነው። ስለዚህ በዚሁ እንቀጥላለን ማለት ነው። እንዴት ነው ዩኒት 3ን ያው ትንሽ ፈጠንም ይያልን አንዳንድ ቦታ የዘገየን ቢሆን ለማየት ሞክረናል። እናንተ ግን በደንብ አርጋችሁ በግላችሁ በሰፊ ሁኔታ ማንበብ ይኖርባችኋል ማለት ነው። ስለዚህ ዩኒት 4ን ዛሬ እንጀምራለን ማለት ነው። ዝግጁ? ኦኬ። This is grade 11 chapter 4 chemical kinetics. Chemical kinetics. Chemical kinetics is under physical chemistry. You know, in chapter 1, what I mean by physical chemistry means, what I mean by the 5 types of chemistry. Therefore, this chemical kinetics is under physical chemistry. Physical chemistry concerned the interaction between especially physics and chemistry. Now, the first introduction part is, all chemical reactions do not proceed at equal speed. Some require a fraction of seconds. The other may take a minute, a hours, months, or even many years, because all reactions proceed not the same time. The other one, what I mean by chemical kinetics? The field of chemistry that is concerned with the rates and mechanisms of chemical reaction is known as chemical kinetics. The field of chemistry that is concerned rates and mechanisms of chemical reaction is known as chemical kinetics. Therefore, the chemical kinetics concerned rates and mechanisms of reaction. Look this some examples: slow reaction and fast reaction. Look, slow reactions: rusting of iron. Rusting of iron, it takes a days. Fermentation, you know, in biology again, what I mean by fermentation means fermentation process, it takes time. Oxidation of copper, souring of milk, geological reactions is an example of slow reaction. Some other examples of fast reaction: firing of a gun is fast reaction. Neutralization reaction, you know, neutralization reaction, acid-base reactions. Acid plus base, salt plus water is fast reaction. Combustion of fuel is fast reaction. Precipitation is a fast reaction. A reaction of active metals with acid, you know, active metals. Therefore, some reaction is fast, some other reactions are slow. Therefore, this chemical kinetics deals about the rates of slow reaction and fast reactions. The rates of a reaction is calculated by dividing the changing concentration of reactants or products with time. That means rates always calculated by changing concentration versus changing time. Concentration of what? Concentration of reactants or concentration of products with time is rates. Therefore, rate of reaction is calculated by dividing the changing concentration of reactants or products with time taken for the change to occur. Rates is changing concentration over changing T. By the way, C means concentration. Concentration usually uses capital letter M. You know capital letter M, molarity. Molarity. Time, SI unit is second. Or this one again possible. Capital letter M means molarity. Molarity means mole per liter. Mole per liter is the unit of molarity. Per second, over second means per second. Again, this is the unit of rates. Therefore, rate is what? Changing concentration over changing T. Usually concentration represented by molarity. Time is by using of SI unit second. Molarity means mole per liter. Over second means per second. This is the unit of what? The unit of rates. When expressed in terms of reactant concentration, The rate of reaction is determined by this equation. Rate expression for reactant, rate expression for product. Look for reactants. Rate is equals to minus change in concentration of reactant over time taken. Simply minus change in concentration over change in T, change in time. Students, why the negative sign can be used for reactant concentration? This negative sign indicates the concentration of the reactant decreases with time. The negative sign indicates what? The concentration of the reactant decreases with time. Therefore, the negative sign indicates the concentration of the reactant decreases. Okay. When expressed in terms of product, for product, rate expression for product, the previous one, rate expression for reactant. This one is rate expression for products. Look, rates is equals to changing concentration of product over time taken. The same expression. The only difference is what? This one is positive in sign. The previous one is negative in sign. For reactant, rate is equals to minus change in concentration over change in T. The negative sign indicates the concentration of the reactant decreases with time. But in the case of product, it uses positive sign. That means R is equals to change in concentration over change in T. In this case, why positive? Because the concentration of the product increases with time. Increases plus, decreases minus. This is the difference between minus and plus for reactant and products. For a simple reaction, A converted into B. You know this one, reactant A. You know this one, a rho. This one, products. Assume A is a reactant, B is product. Rate of reaction is expressed in terms of reactant concentration. Reactant concentration. What is a reactant in this case? The reactant is what? A. Therefore, for A, look, rate is equals to minus change in concentration of A over change of T. This minus indicates, look, rate is equals to minus change in concentration of A over change of T. You know the negative sign, decreases of concentration with time, which means minus as a whole, concentration of A final minus concentration of A initial over T final minus T initial. This is similar to minus change of A over delta T. This minus this one. By the way, for reactant A, which one is higher concentration? The initial concentration or the final concentration? For A, for reactant A, which one is greater? Reactant concentration or the final concentration? Very good. The initial concentration of A greater than the final concentration of A. Why? Because the concentration of the reactant A decreases with time. In the final position, the amount of A is small. Therefore, A final minus A initial, in this case, concentration of A final is less than concentration of A initial. Final is a smaller number. A smaller number minus larger number, this value is negative. Negative times negative, positive. Therefore, rate is always positive. You know T final minus T initial. T initial is already 0. T final is large number minus smaller number. Positive sign is can be indicated. Therefore, rate minus change in A over change of T. A final minus A initial. T final minus T initial. But from this position, please a student uses negative sign. A negative sign. A final. This one is by a concentration. This symbol, please student. This symbol indicates concentration. Concentration. A is reactant. F final. Final concentration. This is initial concentration. For reactant, which one is greater? A final less than A initial. Minus sign is uses. Rate of reaction expressed in terms of product. What is a product in this case? A or B? B is a product. Therefore, rate is positive here. A similar way, for B, rate is equals to changing concentration of B over change of T. Again, for this one is concentration of B final minus concentration of B initial over T final minus T initial. Students, which one is greater? B final or B initial? For B, for product. Very good. B final is greater than B initial because product initial is 0. Larger number minus 0, already positive sign. Positive divided by positive, the sign is positive. In the case of reactant or product, rate is always positive quantity. This is simply the rate expression. The rate expressions for the following reaction is, look, simply A with B, rate minus changing concentration of A over change of T. For B, the only difference is for reactant is minus, for product is plus. The second one, 2A converted into B. Look, the coefficient of A is 2. For coefficient uses fraction. 2A converted into B, rate is equals to minus. You know minus? The concentration of A decreases with time, minus. Because of 2, minus 1 over 2. If this one is 3, minus 1 over 3. If this one is 5, minus 1 over 5, and so on. If this one is already 1, 1 over 1 is 1. 2A means minus 1 over A, changing concentration of A over change of T. For B, what is the coefficient? 1. 1 over 1, already 1. Therefore, changing concentration of B over change of T. This equation generally rate expression. Look, the above reaction indicates that for 2 moles of A, that is disappear, yes, 2 mole of A disappear. For the formation of what? 2 mole of A disappear, 1 mole of B is formed. For the production of 1 mole of B, 2 mole of A must be disappeared. Disappear, 1 mole of B is formed. That is, the rate of disappearance of A is twice the rate of the appearance of B. The disappearance is twice for the production of 1 mole of B. In general, A plus B, it gives C plus D. Please, students, a small letter A, B, C, and D. Small letter A, B, C, and D are stoichiometric coefficients. A, B, C, and D, small letter, are stoichiometric coefficients. Capital letter A and B are reactants. Capital letter C and D are products. In general, the rate expression is this one. What is the coefficient of capital letter A? A. Therefore, it uses minus 1 over A, changing concentration of A over delta T. For B, because of reactants, minus. Because of coefficient B, minus 1 over P. Change of B over delta T. C is what? Product. What is the coefficient of capital letter C, small letter C? Because of product, 1 over C. Remember, this number is 5, 1 over 5. 3, 1 over 3. 2, 1 over 2, and so on. For D, 1 over D, changing concentration of D over delta T. This is for general expressions. For example, write the rate expression for the following reactions in terms of disappearance. By disappearance is always for reactants, not product. Disappearance for reactant, appearance is for product. The disappearance of the reactants and appearance for products. Disappearance is for reactants, appearance is for products, because products are formed, reactants are consumed. This is the terms. Look at the first one. N2 gas plus H2 gas, it gives to ammonia gas. Now, the rate expression is minus changing concentration of N2 over change of T. Please, student, this is over change of T. Again, coefficient of H2 is 3. Because of 3, uses minus 1 over 3, changing concentration of H2 over change of T. Ammonia, The coefficient of ammonia is what? 2. Because of these 2, uses 1 over 2. Changing concentration of ammonia over what? Over change of T. Please, students, change T, change T, change T. This is the rate expressions for this equation. You know this one? Haber process, the production of ammonia. Students, please try this one. Please write the rate expression for the second one. 3O2 gas converted into 2O3 gas. O2, O3. Oxygen, molecule. O3 is what? Ozone. Okay, look, the coefficient of O2 is 3. Because of 3 minus 1 over 3. Changing concentration of O2 over change of T. This is for O2. What about for O3, students? Minus 1 over 2 or plus 1 over 2? Minus 1 over 2? No. Yes? Okay, very good. 1 over 2. 1 over 2, changing concentration of O3 over change of T. 1 over 2 because it is positive. This is minus because of reactant. I think this is very simple. Example 3 is, for this reaction, already 4 mole of ammonia react with 3 mole of O2. It gives 2 mole of N2 and 6 mole of H2. What is given? A rate of formation. Please, formation is important for only products. In this case, the product is N2 and water. Rate of formation of N2 is already given. How much is given? 0.027 mole per liter per second. Why mole per liter per second? Because this is a unit of rates. Rates. At what rate of water is formed? What is given? The rate of formation of N2. What is the question? What is the rate of formation of water? Okay. First, write the rate expressions for water by using coefficient 6. It uses what? 1 over 6. Next, write the rate expression for N2. What is the coefficient 2? It uses minus 1 over 2. Look. For H2, uses 1 over 6. Please, 6 means the coefficient of H2 already. Why positive? Because it's product. 1 over 6, changing concentration of H2 over change of T is equals to 1 over 2, changing concentration of N2 over change of T. The question is, what is the rate of H2O formed? What is the rate of water formed? In this case, what is the coefficient of H2 here? 1 over 6. This 1 over 6 must be cancelled. By what? By multiplying of 6. If this one is 1 over 4, multiplied by 4. If this one is 1 over 5, multiplied by 5. If this one is 1 over 3, multiplied by 3. Because the question is, how many rates of H2O is formed? The rates of H2O is formed. This one is multiplied by 6 because of 1 over 6. Multiplied by 6, the coefficient is 1. Both sides multiplied by 6. This is cancelled. Now, finally, changing concentration of H2 over change of T is equals to 1 over 2 multiplied by 6. 6 over 2. 6 over 2 is how much? 3. 3 times changing concentration of N2 over change of T. 3. The rate of N2 over delta T is given. How much is given? 0.027 of the rate formation of N2 is given. 0.027 is given. But this number is multiplied by 3. 3 multiplied by 0.027 is equals to 0.081. Now, the amount of water formed is greater than the amount of N2. The amount of water formed is greater than the amount of N2. Why? Because of coefficient. The larger the coefficient, the larger the amount of product can be formed. The smaller the coefficient, the smaller amounts can be formed. Coefficient is very important for the amount of substance can be formed. The other important point is factors that affect the rate of chemical reaction. You know, chemical kinetics deals about the rates and mechanisms of reaction. This rate of reaction depends on different factors. Because some chemical reactions are fast. Some chemical reactions are slow. Fast reaction, slow reaction, because of different factors. Therefore, factors that affect the rate of the reaction. What are the factors? What are the major factors that affect the rate of chemical reaction? The first one is the nature of the reacting species. The second one is surface area of solid reactants. By the way, surface area important only for solids. Surface area not important for gases and liquids. Surface area concerned especially for solid substances. The third one, temperature. Temperature is very important. Temperature is a factor. The fourth one, the concentration of the reactants. And the fifth one is the presence or the absence of a catalyst. You know catalyst. Look, the first one. The rates of the nature of the reactants. The rate of a reaction depends on the chemical nature of the substances participating in the reaction. For example, under the same conditions, please students, the same condition means the same temperature, the same concentration, and some other, the same parameters. Different reactions takes place. Example 1. H2, you know hydrogen. H2 reacts rapidly with Cl2. H2 with Cl2. H2 with Cl2, it gives what? To HCl. This is very fast reaction. H2 reacts slowly with N2. The same reactants. H2, another different reactant, Cl2 and N2. Cl2 reacts with H2, N2 is react with 3H2. It gives ammonia, a slow reaction. What is the difference between this reaction and this reaction? The difference is H2? No, because it contains H2, it contains H2. What is the difference? The difference is Cl2 and N2. Cl2 is very active gas. N2 is very inert. Remember in chapter 3, bond order. The bond order of N2 is 3. 3 is triple bond. It requires very large amount of energy. The amount of energy when NN, this bond, break by 945 kilojoule per mole. Very large amount of energy. Therefore, this one is inert. Cl2 is very active gas. Because of Cl2 and N2, because of the nature of the reactants are different, one is fast reaction, the other one is slow reaction. This is because Cl2 is a very active gas, whereas N2 is inert. You know inert. Inert means non-reactive gases. This is because Cl2 is a very active gas, whereas N2 is inert. You know inert. Inert gas means unreactive gas. Because of difference Cl2 and N2, both are the same position in reactant position, but different natures. Cl2 and N2, different rates of reaction. Example 2. Example 2 is iron with nickel. Look, iron and nickel. Iron with oxygen. Iron corrode in atmosphere to form rust. Relatively short times. It produces what? Forms rust. But nickel appears to be unchanged in atmosphere. Therefore, iron affected by oxygen. Iron affected by oxygen, whereas nickel does not affect by oxygen. The other example is sodium. You know sodium. Very reactive element. Sodium reacts with water. Sodium reacts with C2H5OH. You know C2H5OH? Ethanol. This is ethanol. Sodium reacts with water. Sodium reacts with ethanol. Sodium reacts with water. Sodium hydroxide plus H2. Sodium reacts with ethanol. Sodium hydroxide plus H2. The same species. But the first one is fast reaction. The second one is slow reaction. What is the difference? The difference is sodium? No. What is the difference? The difference is water and ethanol. Sodium reacts with water, very fast reaction. It produces what types of sound? Hissing sound, and so on. But sodium with ethanol is slow reaction. It produces sodium hydroxide and H2. Therefore, one is fast reaction, the other one is a slow reaction. The second factor that affects rate of reaction is surface area of solid reactants. Surface area is a factor. Chemical reactions are usually classified as heterogeneous and homogeneous. There are two types of reaction: homogeneous reaction and heterogeneous reaction. Heterogeneous reactions are reactions that involve reactants which exist in different phases or different states. Look, heterogeneous reactions are reactions that involve reactants which exist in different phases or different states. That means gas and liquid, liquid and solid, solid and gas, and so on. These types of reaction is heterogeneous reaction. On the other hand, reactions that occur in one phase only are called homogeneous reactions. Look at this reaction. 2NO gas, it gives NO2 gas plus O2 gas. Look the reactant, gas, 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 all are gas. Look the second reaction, 2SO2 gas plus O2 gas, 2SO3 gas, all are gas. The first reaction and the second reaction is what? Homogeneous reaction. Student, you know homo? Homo? Homo means the same. Geneous means type or kind. Homogeneous, the same type, the same kind, which is similar. Similar. The second one is heterogeneous reaction. Heterogeneous reaction is different states are exist. Look, carbon solid plus oxygen gas, it gives carbon dioxide gas. Carbon is solid, oxygen is gas. The same phase? No, different phase. These types of reaction is heterogeneous reaction. Another example, ammonium nitrate. Ammonium nitrate is solid. Ammonium nitrate, it gives what? Dinitrogen oxide and 2H2O gas. The same state? No. Solid, gas, gas. Therefore, this is a types of heterogeneous reaction. By the way, hetero means different. Geneous, type, different type. This is heterogeneous reaction. The effect of surface area is seen for what types of reaction? Heterogeneous reaction. Surface area is important for heterogeneous reaction. Surface area is important especially for a solid species. Look at this one. An increase in surface area of reactant increases the rate of reaction. When the surface area increases, the rate of the reaction also it increases because many more contact, the contact is increases. The collision increases. Take place between the reactants with high surface area than between the reactants with low surface area. High surface area means high contact. High contact between what? Between solute and solvent. Between, for example, let's take sugar with water. The contact between sugar with water, the rate is increases. The contact between sugar with water is small, the rate is decreases. No, the important point is not sugar. The important point is what types of sugar. Is it a crystal form or is it a powder form? Student, which one is more or easily dissolved in water? Sugar in the forms of crystal or sugar in the forms of powder? Which one is easily soluble in water? Very good. The powder one is easily soluble in water. Why? Because the powder one is smaller in size. Smaller in size means a number of sugar particles contact with the solvent, contact with the water. The contact between water and sugar, it increases, the rate also it increases. The very important point is not sugar. The very important point is what type of sugar. Is it crystal or powder? Similarly, salt. What types of salt? In the forms of crystal or in the forms of powder? Therefore, the powder one is the higher the rate of the reaction. This is because of collision. This is because contact. The contact, the collision increases, the rates of chemical reaction also increases. Heterogeneous reaction mostly involve a solid with a liquid or gas. Yes, heterogeneous reaction is solid with gas, gas with liquid, and so on. Example, HCl reacts faster with powdered chalk. Look, chalk, you know chalk? Students, chalk is soluble in water or not? Chalk. Chalk is insoluble in water because chalk means calcium carbonate. Therefore, HCl reacts faster with powdered chalk than cube or in the forms of crystal chalk. Look, this one, calcium carbonate solid. This calcium carbonate solid exists in the forms of 1, crystal, 2, in the forms of powder. But simply, calcium carbonate solid reacts with HCl, it gives calcium chloride plus water plus carbon dioxide. But the rate is not the same. The powder one is the faster the reaction. The crystal one is the slower the reaction. Therefore, surface area is very important. Similarly, sulfuric acid, H2SO4. Sulfuric acid reacts faster with finely divided iron than large piece of iron. A piece of iron in the forms of powder, fast reaction. Iron in the forms of crystal is slow reaction. Therefore, sulfuric acid with iron, it gives iron sulfate plus H2. But the rate depends on which one is powder, which one is crystal. The powder one is the faster the reaction. Students, in the next class, discuss about the other types of factor, the fourth one and the fifth one. Generally, in today's lesson, discuss about the new chapter, Unit 4, Chemical Kinetics. What I mean by chemical kinetics means? Chemical kinetics is concerned with what? The rates and mechanisms of reaction. Also, rate means what? Changing concentration over changing time. The other one is rate expression for reactant and rate expression for product. Rate expression for reactant, it uses a negative sign. Why a negative sign? Because the concentration of the reactant decreases with time. The other one is rate expression for product. It uses a positive sign. The positive sign indicates the concentration of the product increases with time. Also, the other point is factors that affect the rate of chemical reaction. One is what? Nature of reactant. 2, surface area. And in the next class, discuss about the other types of factors that affect rates of reaction. Until next time, goodbye, student. Goodbye. Thank you very much.